In one hand, explosives and ammunition. In the other hand, fertilizers to reduce undernourishment. The ammonia synthesis process really changed the world. And its demand may even increase with a possible shift to biofuels. Do you know the Haber-Bosch process for ammonia synthesis? Let me guide you through the simulation of this process. The easy equation-oriented simulator comes with several ready-to-use examples. One of these examples is the ammonia plant for the ammonia synthesis process. This is the case. We have several equipment, compressors, separators, a reactor, coolers. We can run the simulation and check the variable values. The feed consists of essentially hydrogen and nitrogen. See the amount of hydrogen we need. But that's the story for another video. So in order to react nitrogen and hydrogen to get ammonia, we need high temperature and pressure. So the first thing to do is to compress the feed. We will do this in two stages. In the first stage, we get around 40 atmospheres. In the second stage, we reach 200 atmospheres. Then the compressed gas goes to the reactor. We are assuming the reactor is big enough to reach equilibrium. Then we are using a Gibbs reactor. Then the products need to be cooled, first with cooling water and then liquid propane to get a stream with -30 degrees Celsius. Then we go to the first stage of separation using a flash. In the vapor phase, we get a stream rich in hydrogen and a few ammonia, but still at high pressure. Then the liquid stream goes to a second separation. In this second stage, we have lower pressure, and on the bottom we will have our product, liquid ammonia. Let's check the composition. We have high purity ammonia. What about the recycle streams? We have two recycle streams in this process. One coming back from the vapor phase of the high pressure flash, we compress, and then this stream is fed to the reactor. The another one from the low pressure flash is mixed with the feed stream. See that we can run the simulation without any special block for recycles. And the convergence is very fast. This is one of the advantages of equation-oriented simulators. And that's it. Thanks for watching.